Hey, welcome to Developer Roadmaps. Today we're going to talk about something called containerization. It's a really core concept that, honestly, solves one of the oldest, most annoying problems in software. We're going to dive into how Docker made this whole thing popular and how it lets us build an app just once and then run it absolutely anywhere. All right, let's jump in.
So to really get why containers are such a game changer, we kind of have to go back in time. We need to look at what life was like before them. And trust me, it was a world defined by a single, incredibly frustrating phrase that every single developer knows by heart.
Ah, yes, but it works on my machine. Come on, if you've ever written a line of code, you've either said this or you've heard it. It's the classic, the classic sign that your app is running perfectly fine on your laptop, but the second you try to move it somewhere else, like to a test server or into production, it just breaks. And that was the big problem that absolutely had to be solved. And that works on my machine problem, it wasn't just some abstract thing. It came from some really painful real-world issues. I'm talking about dependency hell. Where app A needs one version of a library, but app B on the same server needs a different version. Total nightmare. Then you had these inconsistent environments. Your development machine, the staging server, the production server, they all slowly drifted apart. And good luck trying to reproduce a bug then. And setting up a new developer or a new server? It was this long, complicated process with a huge script that was just begging for something to go wrong. So how did we fix this mess? Well, it was an evolution for sure. Way back when, we had bare metal servers, literally physical computers. If you needed a new one, you were waiting days, maybe even weeks. Then came virtual machines, or VMs, and they were a massive step up. You could run multiple isolated computers on a single physical machine, but they were still really heavy and took minutes to boot up, which brings us to containers. They're the next logical step, taking that setup time from minutes down to, seconds. Okay, so what is the big difference here? What makes a container so much faster? It's all about what's being virtualized. A virtual machine pretends to be an entire piece of hardware, so each VM needs to run its own full copy of an operating system on top of that virtual hardware. That's why they're huge, we're talking gigabytes. A container, on the other hand, does something much smarter. It virtualizes the operating system itself. All the containers on a machine share the same host OS kernel, and because they're not carrying around that entire OS, they are unbelievably lightweight and fast. And that efficiency, that speed, that's what made containers the new standard. It's just a fundamentally better, more modern way to package up your software and send it out into the world. So let's break down exactly what we mean by a container. Here's the textbook definition, and it really nails it. A container is a standard package. It wraps up your code and, this is the important part, all of its dependencies. The runtime, the tools, the libraries, the settings, everything. It's all bundled together. And what do you get? You get consistency. The app runs the exact same way on your laptop as it does on the production server. The works on my machine problem? Gone. Okay, let's put this side by side because the difference is just staggering. Look at the size. VMs are in gigabytes. Containers are in megabytes. That's a huge difference in storage and network transfer. Startup speed, minutes versus seconds. That changes everything for development and scaling. Resource overhead, a VM is running a whole OS, so it's high. A container just shares the kernel, so it's super low. Now, VMs do have slightly stronger isolation at the hardware level, but for most apps, the process-level isolation in containers is perfectly fine. It's an incredible trade-off. So how does this all work under the hood? It feels like magic, but it's actually some really clever tech built right into the Linux kernel. We're talking about two key things, namespaces and cgroups. Think of namespaces as giving each container its own little bubble, its own private view of the system, so it can't see other processes or files. Then cgroups are like resource limiters, telling a container, hey, you can only use this much CPU and this much memory. And the best part? A container runtime, like Docker, handles all of this complex stuff for you. Right, so we mentioned runtimes, and this is a key point. The technology for containers existed in Linux for a while, but it was Docker that came along and made it easy for everyone to actually use them. They created a simple, intuitive workflow. And to understand it, we're going to use a little cooking analogy that I think makes it all click. Okay, so every great dish starts with a recipe, right? In the Docker world, that recipe is the Dockerfile. It's just a plain text file. And in it, you write down, step by step, everything you need to build your application's environment.
You'd say something like, start with a basic Linux system, then install Python, then copy my application code inside, and finally, here's the command to run when it starts up. Simple as that. Now, what happens when you follow that recipe? You get a Docker image. And if the Dockerfile is the recipe, the image is like one of those perfectly packaged meal kits, where all the ingredients are pre-measured and ready to go. This image is a self-contained, read-only template. It has your code, your dependencies, everything. And because it's a single package, you can easily send it to your friends, your colleagues, or your servers. And the final step, you take that meal kit, the image, and you cook it. That finished dish, the thing you can actually enjoy, that's your Docker container. It's the live, running version of your application. And the really cool part is you can take that one image, that one meal kit, and spin up as many containers as you want. 1, 10, 1,000. It's the same dish every time. So to recap, the Dockerfile is the recipe, the image is the package, and the container is the final running application. Okay, so that's the basic building block. It's pretty powerful. But let's be real, most modern apps aren't just one single thing, right? They're made up of multiple services working together. So now that we've got the single container down, let's zoom out and see how this all fits into a bigger picture. So when your app has, say, a web front end, a back-end API, and a database, you need to run all three of those containers and have them talk to each other. For that, you use a tool like Docker Compose. It makes running these multi-container apps super simple. And what about standards? Well, the Open Container Initiative, or OCI, makes sure that an image you build with Docker can also be run by other tools, which is great for avoiding lock-in. Now, where do you store these images you build? That's what registries like Docker Hub are for. Think of it like a GitHub for container images. And finally, when you go from a few containers to hundreds or thousands, that's when you need an orchestrator like the famous Kubernetes to manage all that complexity. All right, we've covered a lot of ground, from the core problem to the whole ecosystem. So you've got the fundamentals down. What now? Well, now let's place it on our roadmap and figure out what your next steps should be. Okay, think of this as a checkpoint on your developer journey. Here are 3 things you should focus on next. First, really get a handle on Docker Compose. Learn how to define and run an app with a few different services. It's a skill you'll use all the time. Second, start playing with container registries. Go to Docker Hub, pull some official images, and then try building one of your own and pushing it up there. And third, once you're comfortable with that, it's time to start peeking into the world of orchestration. You don't have to be an expert, but start learning the basic concepts of a tool like Kubernetes. It's the key to running apps at scale. And that really wraps up our tour of containerization. So I'll just leave you with this question to think about. Now that you know you can package any application with all its dependencies into a single standard unit, how is that going to change the way you think about building and shipping software? It's a pretty powerful idea. This is Developer Roadmaps. Map your path, build your career.